on the northeastern coast of Japan, standing tall against the violent tides of the Pacific, there is a wall that can think for itself. It stretches across the rugged coastline for more than 400 continuous kilometers. To put that into perspective, if you got into your car at sunrise and started driving along its perimeter at highway speed, you would still be driving as the sun dropped beneath the horizon. In many stretches, its massive concrete face rises higher than a 5-story apartment complex. It cost over $12 billion to construct, making it one of the most ambitious and expensive civil engineering projects in modern human history. But concrete and steel are only half the story. Hidden inside this monolithic barrier are 443 heavy automated steel gates. And the moment the tectonic plates shift deep under the ocean floor, this wall does not wait for a municipal meeting, a phone call from Tokyo, or even a single human hand to reach for a control switch. It acts entirely on its own. It slams shut within minutes. Nowhere else in the world has anything like this ever been attempted. Not because other nations lacked the imagination, but because no other civilization has been forced to confront the merciless fury of the ocean quite like Japan. This is the definitive story of how an entire nation mobilized its brightest minds to wage war against the sea itself. What happened when the ocean pushed back, and the profound questions that linger behind a $12 billion shield. To truly understand why a nation would encase hundreds of miles of its scenic coastline in solid concrete, we have to go back to the exact afternoon that shattered modern engineering assumptions forever. March 11th, 2011. It was 2:46 p.m. on an otherwise ordinary Friday off the Oshika Peninsula of Tohoku. Deep beneath the ocean surface, along the Japan Trench, where the Pacific Plate dives beneath the North American Plate, a colossal slip occurred. The rupture was catastrophic. A magnitude 9.0 megathrust earthquake, one of the 5 most powerful seismic events recorded since modern seismology began, violently tore through the Earth's crust. For 6 uninterrupted minutes, the entire Japanese archipelago shook violently. Skyscrapers in Tokyo, hundreds of miles away, swayed like grass in the wind. Roads cracked open, bridges twisted, and power grids collapsed instantly. 6 minutes is an eternity when the solid earth beneath your feet turns into liquid motion. But the terrifying reality of that afternoon was that the violent shaking was not the main disaster. The earthquake was merely the opening siren. Deep underwater, the sudden vertical displacement of the seafloor had shoved trillions of gallons of water upward. Less than 30 minutes after the ground stopped shaking, the sea withdrew rapidly, exposing harbors and reefs that had remained submerged for generations. And then, the horizon turned pitch black. The first tsunami surges hit the coast not as ordinary breaking waves, but as a towering, endless wall of dark water. Surges exceeding 15 meters in height, some cresting at over 40 meters in narrow bays, slammed into coastal communities faster than any vehicle or running human could escape. Entire towns vanished in seconds. Concrete homes were ripped from their foundations. Heavy industrial fishing trawlers were lifted like plastic bath toys and deposited on top of 3-story buildings. Cars, train cars, shipping containers, and ancient forests were ground into a toxic battering ram that swept inland, flattening everything in its path before dragging the debris back out into the freezing depths of the Pacific. The catastrophe did not stop at the shoreline. Along the Fukushima coastline, the surging ocean breached protective barriers and drowned the backup diesel generators at the Fukushima Daiichi nuclear power plant. Cooling systems failed, triggering multiple core meltdowns and hydrogen explosions. Over 100,000 residents were evacuated from their ancestral lands, under the threat of radiation, with thousands never permitted to return. In a single afternoon, Japan had suffered an earthquake, a tsunami, and a historic nuclear meltdown. By the time the ocean finally receded, over 18,000 lives were lost or unaccounted for. For coastal engineers around the globe, the devastation delivered a terrifying realization. Japan had not been unprotected. Before 2011, Japan was already regarded as the gold standard of coastal defense. Coastal towns boasted seawalls 10 to 12 meters high, barriers built with state-of-the-art engineering that local communities trusted with their lives. Yet, within 60 minutes, nearly 90% of those existing seawalls failed catastrophically. They were not simply damaged. They were overtopped, scourged from behind, cracked at their foundations, or obliterated completely as if they had never existed. The tragic fate of the town of Taro became the most haunting example. Taro had built what residents proudly called the Great Wall of Japan, a massive double-layered concrete barrier 10 meters high that stretched for nearly 2.5 kilometers. Decades of living behind this formidable shield created a psychological phenomenon known to disaster experts as a false sense of security. When the evacuation sirens blared on March 11th, many residents did not rush to higher ground. They believed their legendary wall would protect them as it had in the past. But the wave that struck Taro was over 15 meters high. It surged straight over the crest, fractured the concrete blocks, and swept through the neighborhoods behind it. Of Taro's population, 181 residents did not survive. Japan learned an agonizing lesson written in concrete and loss. A defensive wall engineered for yesterday's ocean is nothing more than an illusion. Yet, amid the catastrophic destruction that stretched across hundreds of kilometers, one tiny coastal settlement told an entirely different story. That village was Fudai, located in the Iwata prefecture. Decades prior to the 2011 disaster, Fudai was led by a stubborn and uncompromising mayor named Kotaku Wamura. Wamura was not an engineer, but he was a survivor. As a young man, he had lived through the devastating Showa Sanriku tsunami of 1933, and he had heard the horrific oral histories of the 1896 disaster. He had watched his beloved hometown wiped off the map twice in his lifetime. When the Japanese national government began allocating reconstruction funds in the 1960s and 1970s for coastal barriers, most towns settled for standard 10-meter seawalls. Mayor Wamura flatly refused. He demanded the construction of a massive floodgate, spanning the river mouth that ran through the heart of Fudai, accompanied by a protective seawall, and he insisted that the structure had to stand at a staggering height of 15.5 meters. The town council was furious. Local fishermen protested fiercely, arguing that an immense concrete barrier would ruin the scenic beauty of their coast, disrupt their fishing operations, and burden the municipality with unnecessary debt. For years, Wamura was openly mocked across the prefecture as an eccentric, stubborn old man squandering taxpayer money on a concrete monstrosity. When the 15.5-meter floodgate was finally completed in 1984 at a cost of roughly $30 million, it was widely criticized as an expensive monument to paranoia. Kotaku Wamura passed away in 1997, never seeing his controversial vision tested. But on March 11, 2011, the test arrived. When the massive tsunami swept toward Fudai, the wave crested at nearly 20 meters high. It surged violently against the outside harbor, completely destroying the exterior port facilities. But when the colossal wall of water smashed against Wamura's 15.5-meter floodgate, the structure absorbed the tremendous hydraulic shock and held its ground. The water lapped near the top, but the village sitting directly behind the gate remained dry. Homes remained intact, businesses were untouched, and roads were passable. Out of the 3,000 residents living in Fudai, not a single person behind the wall lost their life. The only casualty was an individual who had rushed down to the open harbor outside the gate immediately following the earthquake to secure a fishing boat. The controversial concrete monster had quietly stood guard for 27 years, waiting for the single afternoon where it would save an entire community. Kotaku Wamura had proven something fundamental. When engineering for the ocean, the only margin that matters is the one that seems impossible until the day it happens. Fudai provided the living blueprint. But scaling that concept across hundreds of kilometers of broken, rugged coastline was a challenge of entirely unprecedented magnitude. Following the 2011 catastrophe, the Japanese government made a decision that sounded almost reckless in its ambition. They would not merely rebuild individual seawalls, they would construct a unified 400-kilometer coastal defense network spanning 3 entire prefectures. In most Western nations, a large-scale infrastructure project spanning a fraction of that distance would spend 10 to 15 years trapped in environmental assessments, bureaucratic permitting, zoning disputes, and funding debates before ground was ever broken. Japan resolved to engineer, fund, and build over 400 kilometers of fortified seawalls in roughly a single decade. The sheer logistical and geographical scale should have caused civil engineers to walk away. Instead, they began mobilizing heavy machinery across hundreds of work sites simultaneously. Building a wall against an entire ocean introduces geotechnical nightmares that laymen rarely consider. Along 400 kilometers of tohoku coastline, the geology changes constantly. In one bay, the seabed consists of soft, waterlogged marine clay. A few miles down the coast, it transitions into loose sand, and further along, into fractured granite bedrock. Constructing a uniform barrier across varying terrain guarantees failure. The wall will settle unevenly, crack, and collapse under the immense hydrostatic pressure of a tsunami. Engineers could not build one monolithic wall. They had to design over 400 distinct structural sections, each customized down to the millimeter for the specific soil mechanics beneath it. In areas where the seabed was notoriously soft, construction crews submerged thousands of tons of massive armor stones onto the sea floor, creating synthetic foundation shelves before pouring a single cubic yard of concrete. High-density impermeable geotextile membranes were laid deep beneath the foundations to prevent pressurized saltwater from eroding the substrate from below. In several vulnerable sectors, engineers borrowed core technologies from large-scale hydro dam engineering. They packed impermeable, highly compacted clay cores deep inside the base of the seawall. This design ensured that even if millions of tons of churning ocean water struck the exterior face for hours, the foundation would not wash away or shift on its axis. Where coastal topography created natural funnels that could amplify a tsunami's kinetic energy, the wall's geometry was widened, reinforced with heavy internal steel rebar cages and backed by sloped earthen embankments designed to dissipate wave energy rather than simply absorb it head-on. Foundation pilings were driven up to 25 meters deep into the earth to anchor the structures directly into solid bedrock that the builders could not even see. Construction teams had to work in punishing, narrow tidal windows measured in mere hours. They mixed specialized marine-grade concrete that cured quickly underwater, poured the foundations, anchored the steel reinforcements, and evacuated their heavy machinery before the incoming tide submerged the work site once again. Sophisticated computer fluid dynamics were run for months prior to construction, ensuring the walls were built with specific curvature to deflect incoming surges back toward the open sea while minimizing base scour. The final system rose up to 15 meters high in the most critical zones. But as the concrete hardened, the engineers faced an equally vital operational dilemma. A solid, uninterrupted concrete fortress along the entire coast was practically impossible. Coastal Japan survives on maritime commerce. Hundreds of commercial fishing fleets depart every morning at dawn. Cargo ships require continuous harbor access. Rivers, streams, and storm runoff channels must drain naturally into the Pacific. You cannot simply wall off a nation from its lifeblood and expect society to survive. To solve this, engineers integrated 443 massive steel floodgates directly into the seawall. Under normal conditions, these gates remain wide open, allowing fishermen, commercial vessels, vehicles, and pedestrians to pass freely through the perimeter. But the moment an offshore megathrust earthquake strikes, these gates must close instantly. During the 2011 disaster, dozens of volunteer firefighters and local disaster workers died tragic deaths because they bravely rushed toward the shore to manually crank down mechanical floodgates before the wave struck. Japan resolved that no human being would ever have to sacrifice their life to operate a gate again. The 400-kilometer wall was fitted with an autonomous, sensor-driven response system. Along the coastline and deep on the ocean floor, arrays of seismic accelerometers and pressure gauges continuously monitor the specific frequency signatures of major tectonic ruptures. When a major earthquake is detected, the automated system does not wait for municipal authorization, ministerial sign-offs, or manual operator inputs. The central network instantly triggers emergency locking mechanisms across hundreds of miles. All 443 steel gates lower and lock themselves autonomously within 5 minutes. Think about the psychological shift embedded in that design. This is not an alert system asking a terrified worker to maintain composure in the middle of chaos. It operates like an aircraft's fly-by-wire flight control system, taking over the controls during catastrophic turbulence. The system assumes, entirely correctly, that during a massive disaster, every single human being will be focused on basic survival. Therefore, the defense of the coastline must operate on pure automated instinct. In 2022, the system faced its ultimate real-world examination. A powerful magnitude 7.4 earthquake struck off the coast of Fukushima. While not the apocalyptic scale of 2011, it was an intense, violent seismic event that immediately triggered tsunami warnings across the region. Within seconds of the initial tremor, the autonomous network registered the threat. Across the coastline, warning sirens echoed, and the automated floodgates fired into motion. Every single gate closed and sealed the defensive perimeter before local residents had even finished seeking shelter beneath their tables. No manual levers were pulled, no officials had to risk their lives on the shoreline, and no gates failed to drop. The engineering functioned precisely as conceived. This massive wall is not an isolated marvel. It is the physical manifestation of an engineering philosophy deeply woven into Japanese society. Japan sits directly at the volatile intersection of 4 major tectonic plates: the Pacific, Philippine Sea, Eurasian, and North American plates. It accounts for nearly 20% of the world's most powerful earthquakes. Rather than living in collective denial of this geographical reality, the nation has spent more than a century building an obsession with disaster mitigation. In Tokyo, modern skyscrapers are engineered not to resist seismic shock through rigid strength, but through flexible compliance. Massive hydraulic dampers, counterweight-tuned mass dampers, and flexible steel frames allow 40-story office towers to sway gracefully during an earthquake, dissipating kinetic energy safely. Beneath the railway network, the Shinkansen bullet trains are tethered to the Uridas early warning system. The moment primary seismic compression waves are detected, the system automatically cuts power and engages emergency regenerative brakes, bringing trains traveling at nearly 200 miles per hour to a controlled stop before the destructive secondary shear waves arrive at the tracks. School gymnasiums nationwide are engineered as secondary survival shelters, fully plumbed with emergency water reserves, solar backup grids, and disaster provisions. Detailed tsunami inundation maps are distributed directly to households, indicating precisely how many feet of water could flood their specific doorstep based on multiple historical disaster models. In many parts of the world, disaster preparedness is reactive. A storm hits, communities rebuild what was lost, add minor improvements, and hope the climate spares them in the future. Japan operates on an entirely opposite principle. The disaster will happen again. It is merely a question of when. Therefore, the infrastructure must be built for the worst day imaginable. Yet, despite its technical brilliance, Japan's 400-kilometer seawall is not universally celebrated. In fact, it remains one of the most hotly debated infrastructure projects within Japan itself. For generations, coastal communities in Tohoku derive their identity, livelihood, and spiritual connection from the ocean. When the giant concrete walls were erected, they severed that bond. Fishermen who had spent entire lives reading the subtle moods of the sea from their doorsteps found themselves staring into a grey, 15-meter slab of reinforced concrete. In numerous coastal villages, residents felt the psychological connection to their heritage had been permanently walled off. Marine biologists and environmental scientists raised severe ecological warnings. Coastal ecosystems depend on the continuous exchange of sediment, freshwater runoff, and natural tidal erosion. Hardening an entire coastal fringe with impermeable concrete interrupts the natural drift of sand, damages vital coastal estuaries, and disrupts breeding habitats for countless marine species that sustain local fisheries. Furthermore, some communities consciously rejected the wall altogether. The town of Onagawa chose a radically different path. Instead of encasing their bay in towering concrete, town planners utilized heavy civil machinery to excavate nearby mountains and construct vast artificial plateaus. They elevated the entire town center several stories above sea level, ensuring that even if a historic tsunami struck the harbor, homes, businesses, and municipal infrastructure would stand safely out of reach on high ground. Perhaps the most haunting debate surrounding the mega wall is psychological. Does a massive seawall create the very complacency that proved fatal in 2011? If people believe an impenetrable concrete shield protects them, will they ignore evacuation sirens when the next unprecedented wave approaches? The Japanese government and disaster planners have addressed this dilemma directly. The modern seawall was never engineered to guarantee absolute, impenetrable safety against an infinite ocean. Its true purpose is far more realistic. The wall is designed to buy time. In a major tsunami event, the kinetic resistance provided by a 15-meter barrier slows the incoming hydrodynamic surge, attenuating its velocity and holding back the deluge for 10 to 15 critical minutes. In the brutal mathematics of disaster evacuation, 10 extra minutes is the difference between an entire town reaching the safety of the hillside or being swept away in the valley below. Today, the Great Seawall of Japan stands complete along the Tohoku coast. It is not an abstract proposal, an architectural render, or an empty political promise. It is over 400 kilometers of solid, engineered concrete and steel, standing guard between millions of human lives and the deepest trench of the Pacific Ocean. Its 443 automated gates remain ready, listening continuously for the first subtle tremor beneath the ocean floor. Decades ago, a solitary mayor in a small fishing village was ridiculed for building a wall that everyone thought was far too big, right up until the day the ocean proved him right. Japan chose to listen to that lesson, scaling that stubborn foresight across an entire coastline. The wall remains a monumental reminder that we cannot tame the raw forces of our planet, but with uncompromising engineering, profound foresight, and the courage to prepare for the unthinkable, we can ensure that when the ocean tests us again, we will be ready. If you found this deep dive into civil engineering and disaster survival compelling, be sure to hit the like button, subscribe to the channel, and turn on all notifications so you never miss our upcoming documentaries. Drop a comment below letting us know. Do you think massive seawalls are the right answer to rising sea levels and natural disasters, or should we be rethinking where we build our cities altogether? Thank you for watching, and stay tuned for the next story.